Okay, so I should have done this one yesterday, but that's okay. We'll finish off that last lesson by looking at this, where we're still factoring expressions. And in this case here, you've got two terms. Each term has an expression or a factor with a base of x squared minus 5. So in the first term, the power on the x squared minus 5 is positive a half. In the second term, negative a half. And we saw yesterday that when you're looking for a common factor involving bases, common bases with different powers, you want to take out the power that's the smallest, which in this case would be a power of negative 1/2. So x squared minus 5 to the negative a half would be our common factor. And to get the other factor, you divide each term by the common factor. So when we divide x squared minus 5 to the power a half by x squared minus 5 to the power negative a half, you're dividing powers with the same base. Subtract the exponents, keep the base the same. So this will be x squared minus 5, and it'll be 1/2 minus negative a half. And then for the second term, when you divide this full second term by x squared minus 5 to the negative a half, you'll be left with 4, and the x squared minus 5 to the negative a half would cancel. Because you're dividing powers with the same base, the exponents are the same, so you're dividing something by itself, they will cancel. And the reason they cancel is because when you subtract the exponents, it'll be negative a half, take away negative a half. And the minus minus becomes a plus positive. So you're going to get x squared minus 5 to the power 0, which is 1, times the negative 4, which gives you negative 4. So if we write this out, we have x squared minus 5 to the negative a half. And then you're going to have x squared minus 5, because, again, the minus minus here becomes plus positive. You'll get 1/2 plus a half, which is 1. X squared minus 5 to the 1, or just x squared minus 5, minus 4. And negative 5 take away 4 is negative 9. So that gives us x squared minus 9, which is difference of squares. Factors are x plus 3, x minus 3. So that's done factoring. Now, if you're checking answers in the back of the book, I think it's normal in math that we don't leave answers with negative exponents. So the one thing that would likely happen here is the x plus 3, x minus 3 would stay on top, and then that first factor would move to the bottom, and it would be x squared minus 5 to the positive a half, because normally in math we do not write answers with negative exponents. We make the exponents positive by moving it from top to bottom or bottom to top. Shansamania. We need to start a GoFundMe page so you can get some pants that aren't full of holes. You're okay? You do want to start a GoFundMe page? You do want to start a GoFundMe page to get some pants that aren't full of holes? You're okay? Okay? So that would be the final expression, the final factors. All right, so remember that we're working towards Shansamania. You have a story to tell because we all want to hear it. Don't just tell your stories to Brighton and Jayhead. We're a family here.
Seems like she almost got the car accident.
Oh boy. Sounds like you were completely at fault to me. Okay, So remember, we're working towards evaluating limits. We talked about this yesterday, right? And the concept of a limit is you're going to find what the value of a function is approaching as x, or whatever the variable is approaching some value. And in many cases, that value is a non-permissive value. So we need to do something to that function to get rid of the non-permissive value on the bottom. And one of those somethings that we will do is to factor. And then in some cases, when you factor, you'll be able to cancel a factor on the top and the bottom. And that one part of the denominator that was giving you a non-permissive value will be gone. And then you can evaluate the expression for that certain number that x is approaching. So one of the tricks that we use for evaluating limits is factoring. Here's another trick that we're going to use, and that is rationalizing either the numerator or the denominator. Now in 20-1, you spent a couple lessons talking about rationalizing denominators. We just finished saying that in math, we normally don't write answers with negative exponents. Well, another thing that we don't normally do is leave expressions with a radical in the denominator. And in 20-1, we looked at two different types, where the denominator was a monomial, the radical part was a part of a monomial, and in those cases, we multiplied top and bottom just by the radical part of the denominator. And then we also saw that when the radical involved a binomial, we multiply top and bottom by the conjugate. The conjugate, remember, is what you get when you factor difference of squares. Same two terms, different sign in between. Okay? So, as it says here, a rational expression is not in simplest form if it contains a radical in the denominator. These radical denominators must be rationalized, and so that's what we're going to do here. And again, this is another one of the tricks we're going to have in our bag to allow us to evaluate certain limits. So in these first couple examples, the denominator is just a single term, a monomial. And when that happens, you multiply top and bottom by whatever the radical part of the denominator is, which in the case of question 1 is root 2. You multiply top and bottom right 2. When you have any kind of rational expression, if you multiply top and bottom by the same value, it doesn't change the value of that expression. Same if you divide top and bottom by the same number. You could add and subtract the same value to both sides, both top and bottom. Again, it wouldn't change the value of that expression. But in this case, we're trying to get rid of the radical part of the denominator. So we multiply top and bottom by root 2. So on top, you're going to have 3 times root 2. And on the bottom, root 2 times root 2 is root 4, which is 2. There is a rule for multiplying radicals that you would have learned about in 20-1 that basically says root a times root a is a. And that's what we're doing here. Root 2 times root 2 is 2. So this expression has the same value that we started with, and you can use your calculator just to confirm that. The original expression was 3 divided by root 2. It's that irrational number, a non-repeating, non-terminating decimal. Well, that should be equivalent to 3 root 2 over 2. And it is. We haven't changed the value. We just changed how it looks. We no longer have a radical in the denominator. Okay, so same thing with this next one. Now, you don't have to multiply top and bottom by 2 root 3, although if you did, it wouldn't really matter. Once you simplify, you'd get the same answer. You only have to multiply by the radical part, the root 3. So that gives us negative 3 root 3 all over. On the bottom, it's 2 times root 3 times root 3. Root 3 times root 3 is 3. Times the 2 is 6. And now we can simplify a little bit more by dividing top and bottom by 3. And we'll get negative root 3 over 2. So there's the answer. For question 3, we'd multiply top and bottom by root 2. But the other thing we could do here is simplify a little bit before we start by dividing top and bottom by 2 as well. And that makes things a little bit simpler. Again, you'd get the same answer if you didn't do this. If you simplified after you did your multiplying, you would get the same answer. So on top, we're going to be left with 2 root 2 all over 3 times root 2 is 2, so 3 times 2, which is 6. And this becomes root 2 over 3 when we divide top and bottom by 2. And once again, if we want to, we can use our calculator to check our answer. We have 4 divided by, now I'm going to put the 6 root 2 in brackets in my calculator just to make sure that it all stays together in the denominator. It's that irrational number, and then that should be equal to root 2 over 3, and it is. So again, we haven't changed the value of the expression, we've just changed how it looks. These next ones, the denominators are binomials, so this is where you multiply top and bottom by the conjugate. The conjugate of root 2 plus 1 would be root 2 minus 1. Now, I'm not going to multiply out the top. If you do, it's not a problem. But normally we leave the top and bottom in factored form, normally, because the whole point of doing this is so that we can cancel some factors, okay, when we get into evaluating limits. But the bottom I will need to multiply out because the whole point of why I'm multiplying by root 2 minus 1 is to get rid of the radical part of the denominator. So multiplying this out, the front terms, root 2 times root 2 is 2. The outer product is negative root 2. The inner product is positive root 2. They cancel. This is why we multiply by the conjugate. So those terms involving the radicals will cancel. And the last terms, 1 times negative 1 is negative 1. So we've got 2 times root 2 minus 1 all over. Again, the root 2's cancel. So you're left with 2 minus 1, which is 1, or 2 bracket root 2 minus 1. Question 5, you're going to multiply top and bottom by the conjugate, which is 2 plus root 3. The conjugate of the denominator. So that'll give us root 3 bracket 2 plus root 3 on top. On the bottom, when you multiply those out, 2 times 2 is 4. Now, the outer terms, the outer products and the inner products will cancel. The outer products would be positive 2 root 3. The inner products would be negative 2 root 3. They cancel. So I'm not even going to write them down. I'll just go straight to multiply the two last terms together. A negative times a positive is a negative. Root 3 times root 3 is 3. 4 minus 3 is 1, so you're just left with root 3 bracket 2 plus root 3. And again, you can always check them on your calculator. I would keep the denominator in brackets, 2 minus root 3. So that's the value of the original expression. That should be equivalent to what we got as our simplified expression. And it is. So it checks. Same value as what we started with. It just looks different. We no longer have any denominator, including a radical denominator. So the difference here is now the top and bottom are both binomial. So we're going to have to FOIL out on both the top and the bottom. But we are trying to rationalize the denominator, so we need to multiply top and bottom by the conjugate of the denominator. Same two terms, just with the opposite sign in between. And whatever you do to the bottom, you have to do the same thing to the top. So on top, we need to FOIL those out. Root 2 times 3 is 3 root 2. The outer product, a positive times a negative is a negative. You're going to have root 2 times negative 2 root 2. So it's negative 2 times root 2 times root 2. Root 2 times root 2 is 2. So that's what you get when you multiply the outer terms together. The inner terms, negative 1 times 3 is minus 3. And the last terms, a negative times a negative is a positive. It's going to be 1 times 2 root 2, which is 2 root 2. And on the bottom, yes, sir. We could, but I already know that it's not going to cancel with anything. So this is going to allow us to actually simplify it more. So on the bottom, when we FOIL, we know the outer and inner products will cancel. So we'll just multiply the front terms together. 3 times 3 is 9. And when you multiply the last terms together, a positive times a negative is a negative. 2 times 2 is 4. And then root 2 times root 2 is 2. So it's 4 times 2, which is 8. And on the bottom, 9 minus 8 is 1. So all we have left to do is simplify the top. And we've got some like terms here. The 3 root 2, the plus 2 root 2, those are like terms. They are both multiples of root 2, so we can combine them. If you have 3 of something and you add 2 more, that gives you 5 of those things, 5 root 2s. Notice the radical doesn't change. They're like terms. You're adding them together. So your final expression involves just more root 2s. And then you have negative 2 times 2, which is negative 4. Take away 3 is negative 7 over 9 minus 8, which is 1. So there's your final simplified answer. And like we've been doing, you can always use your calculator to check to make sure the expression that you ended up with is the same as what you started with. All right, so for number 7, you're trying to rationalize the denominator, so you need to multiply top and bottom by the conjugate of the denominator, which will be 2 plus 5 root 5. So the front terms, 2 times 2 is 4 root 5. The outer products, the coefficients, I don't know why I put that extra bracket in there. I'm going to get rid of it right now. It should just be 5 root 5. So the outer products, 2 times the 5 is plus 10. The root 5 times the root 5 is 5. The inner products, just 2 times 3, which is 6. The last terms, 3 times 5 is 15 root 5. And on the bottom, when you multiply the front terms together, 2 times 2 is 4. Again, the outer products would be 10 root 5. The inner products minus 10 root 5. They cancel. The last terms, negative 5 times 5 is negative 25. And then root 5 times root 5 is 5. And so on top, I can combine the root 5s together. If I have 4 of something and I add 15 more, that gives me 19 of those things, 19 root 5s. As well on top, I've got 10 times 5, which is 50, plus 6 is 56. And on the bottom, it's going to be 4 take away 125. That's negative 121. There's the final expression with a rational denominator. And just for fun, let's check. The numerator I'll keep in brackets is 2 root 5 plus 3. Close the bracket. Divided by in brackets 2 minus 5 root 5. Has that value. So we'll check our simplified expression. 19 root 5 plus 56 in brackets, all divided by negative 121. Exactly the same value. So we know that our final expression is correct. Right, so now these ones are getting a little more complicated from what you would have seen in 20-1. What would we do for this next one, Brighton? Which is what? The root of x minus 1 minus 2. Well, I probably wouldn't have taken that. Oh, yeah, I guess I would have.
Yeah.
We should have bet a pop on that. Yeah. So this one, I think I will leave the top in factored form. And the reason why is because the first number, the first factor, is a 2. So if I get something on the denominator that ends up with an even value, then I know that I'll be able to simplify. So on the bottom, when you FOIL this out, whoops, the front terms, the root of x minus 1 times the root of x minus 1 is what, Jihad? Just x minus 1, right? Root a times root a is a. So you're going to get x minus 1. Again, the outer and inner products will cancel. The outer products would be negative 2 times the root of x minus 1. The inners would be positive 2 times the root of x minus 1. They'll cancel. And the last terms, 2 times negative 2 is negative 4. And in this case, it's not going to give us an even value on the bottom. But that doesn't matter. I'll still leave the top in factored form. Because on the bottom, you're going to get x minus 5. Negative 1 take away 4 is negative 5. Okay. Now you cannot cancel this, or sorry, you cannot check this on the calculator directly because we have variables in there, right? So that's something else that's different from what we looked at already today. But you could still check it if you just chose some arbitrary value for x, any number, as long as it is not a non-permissive number, okay, which I don't think there are any here. No, because plus 5 take away 1 is 4. The root of 4 is 2. Plus 2 gives you positive 4 on the bottom. The only way you get a non-permissive value is if the root of x minus 1 equaled negative 2. If you're checking the simplified expression, that is correct. 5 would be non-permissive, but not for the original. There is no non-permissive for the original, but yes, you are correct. You couldn't use 5 because it would give you 0 in the denominator for the simplified expression. All right, so for question 9, you need to multiply top and bottom by the conjugate of the denominator. Same two terms, just with the opposite sign in between. It would be the root of x minus 2 plus the root of x plus 1. Top and bottom. So I'll leave the top in factored form. And on the bottom, when I FOIL this out, the front term's root of x minus 2 times the root of x minus 2 is just x minus 2. The outer and inner terms will cancel. When I go to the last terms and I multiply them together, got to be a little careful here. You're multiplying a negative times a positive, which is a negative. Root of x plus 1 times root of x plus 1 is x plus 1. But notice I'm putting it in brackets because you have to subtract all of it from the x minus 2. We can put the x minus 2 in brackets as well if we want. It doesn't really change anything, no. But you have to put that second product, the x plus 1, in brackets. You're subtracting all of it. And a minus sign in front of the bracket changes all the signs inside. So we're going to have the x squared bracket root x minus 2 plus root x plus 1. And on the bottom, the x's will cancel. When you remove the brackets in front of the negative sign in front of that second bracket, changes all the signs inside. So you'll get x, take away x, which cancels, and you'll get negative 2, take away 1, which is negative 3. And there's the final simplified answer. So again, these ones are a little more complicated than what you would have seen in 20-1. You're going to see as we go through this course, it's heavy in algebra. I think this course is easier than 30-1 just because it flows so much nicer. But the requirement is you've got to be good at algebra because there's lots of it that we're going to be doing. And as long as you take your time, you all have the skills to do it. Okay, you've made it this far in high school mathematics, you all have the skills to do it. Just take your time. You take too many shortcuts, that's when mistakes are going to get made. Sometimes the numerator will need to be rationalized. And again, this is leading towards simplifying expressions so we can evaluate limits. And as we get into it, you will see it'll be obvious what you have to do to that expression in order to get rid of the non-permissive value part of the expression. Some cases you'll have to rationalize the denominator. In some cases you'll have to rationalize the numerator. So let's do a few examples where we have to rationalize the numerator. And in this case, we would multiply top and bottom by the conjugate of the numerator, which would be the root of x take away 2. So when I multiply the top out, root x times root x is x. The outer and inner products will cancel. The outer products would be negative 2 root x, the inner positive 2 root x, they cancel. The last terms, 2 times negative 2 is negative 4. So the numerator will become x minus 4. And if you look at what the denominator is right now, there are 2 factors there. That first factor is x minus 4. The second factor would be the root of x minus 2. We would not multiply these out. We would keep them in factored form because the x minus 4s would cancel. So again, as I said, in most cases, it'll become obvious whether you should multiply out or leave them in factored form. And in this case, because we have a x minus 4 on the top, we have a factor of x minus 4 on the bottom, so we would cancel those two, and there's the final answer. The question says to rationalize the numerator, which we did. If you now rationalize the denominator, which is what we're used to doing, you'd end up with a radical in the numerator, and then we'd have to go back and get rid of it again, and we'd end up with exactly what we just have. So we stop there. Question 2. We've got a denominator in the numerator. So what I would first do here is get rid of that denominator in the numerator, and you do that by multiplying all of the terms on the top and the bottom by root x. We're multiplying top and bottom by the same thing, so we're not changing the value of it, but we're just making it easier to work with. We're getting rid of the denominator in the numerator because those root x's would cancel. That's the whole reason why we're multiplying everything by root x. So that gives us 1 plus 2 root x over x root x plus 2 root x. And now we will rationalize the numerator by multiplying by 1 minus 2 root x, the conjugate. So on top, 1 times 1 is 1. The outer and inner products will cancel. So now I'm just going to multiply the last terms together. A positive 2 times a negative 2 is negative 4, and root x times root x is x. And on the bottom, I don't think it really matters here whether you multiply them out or leave them in factored form. I don't think it'll matter, but let's multiply them out. The front terms, x root x times 1 is x root x. The outer products, a negative times a positive is a negative. The coefficients, 2 times x. And then root x times root x is another x, so that'll become 2x squared. The inner products, 1 times 2 root x is 2 root x. And the last terms, a positive times a negative is a negative. 2 times 2 is 4. And root x times root x is x. Brighton, can you cancel the 4 x's? You cannot cancel the 4 x's because you cannot cancel part of a binomial or part of any polynomial. You have to be able to cancel the same factor in all terms. So you cannot cancel the 4 x's. There's our final simplified answer. So for number 3, we're going to multiply top and bottom by the conjugate of the numerator, which would be x root x plus 9. So when we FOIL out the top, x times x is x squared. And then when you multiply the root x by the root x, you'll get another x. The outer products would be positive 9x root x. The inner product would be negative 9x root x. They cancel. The last term's negative 9 times positive 9 is negative 81. On the bottom, in this case, I'm going to leave it in factored form. Only because I have one factor of x squared, so maybe we might end up with something where we have x's and all the terms on top. I don't think we will, but that's okay. Now, the top would be x cubed minus 81 all over x squared bracket x root x plus 9. And when we look at the top, you might want to check for difference of cubes because you have a binomial. The first term is a perfect cube, but 81 isn't. Okay? So we would not factor that as difference of cubes. There's your final expression. And again, you cannot cancel the x squared on the bottom into the x cubed on top because you'd be breaking up that binomial on top. You have to be able to cancel the same factor in all terms. And number 4, the conjugate of the top would be the root of x plus 4 take away 2. When you multiply the front terms together on top, the root of x plus 4 times the root of x plus 4 is x plus 4. The outer products would be negative 2 root x plus 4. The inner, positive 2 root x plus 4. They cancel. And the last terms, 2 times negative 2 is negative 4. So obviously on top, the 4's are going to cancel. And on the bottom, well, I should say before that, you're just left with x on top, right? The bottom has a factor of x, so I would definitely not multiply these out. I would leave the bottom in factored form because I can cancel the x's on top and bottom. So again, the top, when you get rid of the 4's, is just x. The bottom has a factor of x as well. They will cancel. When you divide top and bottom by x, you're left with 1 on top. So it's going to be 1 over the root of x plus 4. Take away 2. And there's the final simplified answer with the numerator rationalized. So you can work on those questions on page 4. I will post the solutions to Google Classroom so you can check your work. Okay?